In this video I'm going to look at the signals going in and out of the electric steering lock just here, and I'm going to start with the one on the right hand side. It's a white wire going to pin 3 on the ELV, and let's see what happens when I just don't do anything. So let's look at the starting position, and then what we'll do is we'll look at what happens when we put the key in the key holder. Okay, at this point we've got power enabled to the car, so my isolator is activated, but we haven't put the key in the slot. So you can see if I just ground this yellow, we're looking at the yellow trace, there's the 0 line. Put it back to DC coupled, and we've got basically, it says 5 volts per square, so we've got about 12 volts there, so no big surprise there. Now what I'm going to do is I'm going to put it in single shot mode. Okay, so we've got it set up to now trigger. It will trigger on a rising edge actually of a signal. And I've got the time base set to 500 microseconds or half a millisecond per square. So let's now plug the key in. Okay, so you can see that we actually get some form of data signal on that white wire. I must admit, I thought that white wire was just a power wire, but it's not. So we've got some sort of signal on there. We can look at, oh no, it's gone beyond the end of the buffer, of course, because it's triggered once. That's what we're expecting on the white wire when we put the key in. Now let's clear that, set it to trigger again, and I'll take the key out. Okay, and you can see again we've got a signal on that wire. Now just to be clear, because the way I've got the oscilloscope set up, when I clear it like that, it looks as though there's no signal on that wire or no voltage. It doesn't mean that, it just means the voltage is continuously on that wire, the 12 volts. Yeah, it's not until I put the key in or take it out that it actually triggers the scope. Okay, so that's what we're expecting on the white wire. Just a quick note to clarify what we're seeing here. We're seeing a digital message flowing from the CAS to the ELV along that white wire bus, but also we could be seeing them in the other direction. So according to the documentation, this is a bidirectional bus, so we may see signals flowing from the ELV back to the CAS unit, but of course without a decode of those messages we can't tell which way things are flowing here. The brown wire is simply a ground, so it goes to one of the ground blocks, one of the chassis blocks on the right hand side. This is a right hand drive car. On the right hand side of the passenger compartment, just below, sort of behind and to the right of where the accelerator pedal is located. So that's where you find that earth or that ground. So let's look at pin number 2 now, which is black and yellow. Right, what I've done is I've put the black and yellow wire on the yellow trace at the top, and there's a black and brown wire that goes into pin 4. I've put that on the blue trace at the bottom. At the moment there's no power on the car, so what you're seeing is just noise. So let's put some power on the car. Okay, so that's with the key in the latch, the key in the key holder. What I will do is I'll switch on terminal 15 just to see what happens. Not a lot. Doesn't look very different, does it? So turn off terminal 15. This is just user error. I've set the trigger level too low on the scope and it's triggering on other patterns, but it's interesting, there are multiple patterns there. Okay, let's take the key out. Okay. we're back to something a bit different. That's very strange. It's quite weird, isn't it? I'm not. Let's try putting the key in again. Yeah. Okay. All right. So I'm pretty certain that this is all related to sensing whether the latch on the steering column has released the steering column or whether it's still locked up. So we seem to have two distinct functions here. We've got the white wire, which seems to drive the motor. Probably not directly, it's obviously sending a signal that causes the steering lock to drive the motor to unlatch the lock on the steering wheel. And then we've got the other two wires, the two black and yellow and black and brown, and what they're doing is they're detecting the position of the latch using a Hall effect sensor, and so it'll be for the CAS to interpret this signal and convert it into something digital and meaningful. I need to jump in here with a correction. This isn't Hall effect. This is it's either an inductive or capacitive proximity detector, and I suspect the yellow trace is probably the input signal and the blue one is a return signal. And yeah, it's just detecting the position of the latch in the steering column using a proximity detector. I noticed one thing, that not only did the frequencies change when we saw it change when the latch was closed, we also, if you notice, there's a phase shift in those little pulsed attempts, checks of the situation. Whereas these two signals are in phase, the other ones were out of phase. So I suspect that's got something to do with the detection, but none of this detracts from the fact that these signals represent normal operation. So just to summarise on this, key out looks like this, with you'll see occasional little blips of sine wave like that. I don't know if it's sort of probing and testing, but you see occasional things like that, and then the majority of the time it looks like this. And then as soon as we put the key in, it immediately changes to that. And I'm guessing to the CAS that means the steering lock is unlatched. These measurements were all done with an ELV emulator in place rather than a real steering lock, but I'm sure you can appreciate that if that didn't emulate the steering lock accurately, this whole thing wouldn't work. So I'm confident with these signals. So in summary, regarding the white wire, obviously you need to see a continuous 12 volts when you're not putting the key in and out of the slot. So we need continuous power. When you do put the key in and out of the slot, if you don't see signals on that white wire, then either the CAS is faulty or the something upstream from the CAS, like the key holder, the key station or the key itself or something like that. Something is not enabling that lock to undo. If it was a wiring fault, then obviously you wouldn't see the continuous 12 volts. So providing you check that out first, then you should be good to assume the wiring's good from the CAS to the steering lock. On the other side, the black and brown and black and yellow wires, which seem to be, providing the signal from the Hall effect device, if you don't see those, then providing you have power and providing you have a good earth on that brown wire, that would seem to indicate that there's a problem with the steering lock itself. Now there are two issues. Could be with the steering lock. There could be a problem with the internals, the components, the electronics, but also you've got to consider that maybe the lock isn't unlatching, because it's jammed or something. So those are the things to check out. Okay, I hope you found that useful, and I'll catch you on the next one.